Welcome to Genius Connect. Please subscribe and share.
Hello everyone, Namaskar. I am Purvi Gohil, Faculty of Mathematics at Genius English Medium School. In my previous video, the types of number, we have discussed till rational numbers. Now we will discuss about irrational numbers. As I told you, the rational numbers are numbers which can be represented in a P upon Q form where Q is a non-zero integer. So, the definition clarifies itself that the numbers which cannot be represented in form of P upon Q are irrational numbers. What are they? The numbers which is having non-terminating and non-recurring decimal places. That means if I write 1 upon 3, it is a rational number because it has a recurring value. The pattern repeats itself. But if I try to write down the number which is a pi, vary our own non-constant, right? What is the value? You will say 3.14, but this is the approximate value which we are taking. What is pi basically? It is a ratio of a circumference of a circle with its diameter. Now when you will try to find out a ratio of these two, the circumference and the diameter, will not be able to get any perfect answer. Doesn't matter how long division you will be doing, you won't be getting any answer. The division will not end. So this number is known as a non-repeating, non-terminating decimal. And such type of numbers are known as irrational numbers. Now, the category of irrational number we can bifurcate in two parts: transcendental and algebraic. What is algebraic irrational numbers? I have discussed about pi. There is one another constant is e, which is the base of logarithmic. These both numbers are transcendental. Now, first you understand what is algebraic irrational numbers. Algebraic irrational number is a root of any polynomial, zero polynomial, which gives you the square roots which we are not able to find, the non-perfect square numbers. Like if I try to find out the square root of 2, I will not be able to find out. So the square root of 2 is also an irrational number, and that number is known as the algebraic irrational number. But whereas pi and e are not the root of any 0-degree polynomial, but then also they are irrational numbers. So these numbers are known as transcendental numbers. Now as we move on, the mathematics has developed. Our wishes, our demands, our hopes, our imagination grows, and we try to find out the reasons, the logic behind the smallest things and the biggest things, and it leads us to find out the value of negative numbers also. When I try to find out all these things, it leads me to such kind of numbers which are non-real. Till now whatever we have discussed, those all numbers are real. They exist in world. Now you will ask me that do pi exist in real world? Yes, you are using circle, and whenever we will talk about circle, the pi is there because each circle have diameter, each circle have their circumference. We are using squares, we are using rectangles. The diagonal of square and rectangle, you will never be try to find out the value of it. Now the set of real number can be represented as r, that we know. I was talking about the numbers which does not exist in our real life. Those numbers are imaginary numbers. Why do we use them? As I told you, we need to find out the square root of negative numbers. Right now you might feel that it can't be possible because square of any number cannot be negative. But when we do the complex calculation of a universe, we need to find out such things. And those numbers are imaginary numbers. We have developed a number I, whose square root is -1. If I'll write down the square of I, it is 1. So these all things are counted as the imaginary numbers, and when I'll add this imaginary number to the real number, I'll be getting the complex number. The set of complex number can be represented as C, and these numbers are very important in mathematics. Thank you, friends.
I hope you all would have enjoyed this video. Subscribe to Genius Connect and put on the notification to receive more such videos. Like and share this video too. Thanks for watching.